This question is on turning effect of forces. You are given that the man is holding on to a light stick that's over here, and one end of the stick is connected to a load which is 24 Newton and it's resting on the shoulder. So P will be acting as a pivot, and you support the whole stick with a force here using your right hand. Now, since there's no mention about the mass of the stick, you can treat it as weightless. So, and assuming this is principle of moment, the stick is in equilibrium. So there are two conditions that I need you to know. Firstly, principle of moment, that means to say your anti-clockwise moment due to the weight of the load must be equals to the clockwise moment due to the force F. And of course, another thing, please do not forget, because this is equilibrium, you can treat the stick as being at rest. So the net force that's acting on the stick will be 0 Newton. So for this context, 24 and F are both downward. That means to say the force at point P on the stick by the shoulder has to be an upward force. So you can actually write the equation P, which is the total upward force, equals to the total downward force 24 plus F. You have another equation here. Now to solve for P, if you know this, to solve for P will be actually quite straightforward, but it's actually quite tedious. There's actually a shortcut, and I'll go through that at the end of the video, so do watch the whole video. Let's start with the usual method. Most students will actually find the force F using principle of moment. Anti-clockwise equals to clockwise, and anti-clockwise is due to the load 24 times the perpendicular distance all the way to the pivot 0.5, and the unknown force by the hand times 0.3, and you will get 40. Then you will use your net force equals to 0. The force at P equals to 24 plus F, which is 40. That's why you get 64 Newton. So the answer will be D. So this is the usual way, but slightly longer. So what's the shortcut? Actually, for a system that is in equilibrium, you can actually choose to take pivot about any point. So instead of the usual P, I can take my pivot at the hand here. And then we're going to use principle of moment to solve. Anti-clockwise equals to clockwise moment, and the anti-clockwise is still the same, 24, but the total distance from the line of force all the way to the pivot now will be 0.80, and the clockwise, this has to be the clockwise by the force at P times the distance, which is 0.3, and if you work out, P will be 64 straight away. So if you know the concept of you can take pivot about any point, I can actually skip this step to find F. Okay, so hopefully this video can help you to understand. Thank you.